AP Calculus ABBC Exam Review Differential Calculus Fundamentals Question 7. Comparing features of functions: odd, relative maxima, y-intercepts, periodic. F is a function defined on all real numbers. Its formula is given below. For those of you who want a concrete definition and examples of real numbers are the type of number we normally use, such as 1, 15.8, negative 0.3, 3/4, etc. Real numbers can be positive or negative, large or small, whole numbers or decimal numbers. These are all categories of real numbers. They are called real numbers because they are not imaginary numbers. Imaginary numbers are of the form I. That is, there is some multiple of I where I is defined as the square root of -1. G is a function defined on all real numbers between -7, and 7 inclusive. An inclusive range of numbers includes the first number, which in this case is -7, and the last number, which in this case is 7, and all the numbers in between. Okay? It's important to make this distinction because some functions are non-inclusive, meaning that there's a hole at the boundaries, which in this case are -7 and 7. And for those of you who want a concrete definition and examples of real numbers are of the type 1, 15.8. In short, they're all the numbers we typically use except for a few. -0.3, and we also have something like 3/4. Real numbers can be positive or negative, large or small, whole numbers or decimal numbers. These are all categories of real numbers. They are called real numbers because they are not imaginary numbers. Again, imaginary numbers are some multiple of I, where I is defined as the square root of -1. So this is the graph given below here for the function g. Okay, so this is function g in terms of its x values. Now the question I would like to pose to you is which features are shared by f of x and g of x? Is it that they are both odd? Do they have a relative maxima at the same x value? Is it that they both have the same y-intercept? Or are they both periodic functions? Now let's ascertain whether or not option 1 is in fact a correct selection. A simple visual inspection of the function g of x reveals that it is in fact an odd function because 1, it passes through the origin. That's definitely a requirement. And 2, it will look the same if we rotate it 180 degrees about the origin, either in a counterclockwise or clockwise direction, okay? And also, you have to notice that g of negative x is equivalent to negative g of x. So let's pick a point to prove this. Let's see, for simplicity, I'm just going to pick negative 3. So g of negative 3 should be equivalent to negative g of 3. So g of negative 3 is going to yield a y value of 2. Therefore, negative g of 3 should also yield a y value of 2. So g of 3 is going to be negative 2, and negative times a negative 2 equals 2. Okay, so that will yield a 2. So therefore, that statement is true. And this equation is the defining stipulation for an odd function, just in case you're not given a graph like this where you can visually inspect the function. Okay? Now we're going to determine whether or not f of x equals negative x squared minus 6x plus 2 is an odd function. And we're going to see that it's not. We're going to prove this by showing that f of negative 1 is not equivalent to negative f of 1. Okay? So f of negative 1 equals negative 1 squared. We're just substituting negative 1 in for the x variable, minus 6 times negative 1 plus 2. And when we combine terms, we're going to see that negative 1 plus 6 plus 2 is our reduced equation, and this is all equivalent to 7. Okay? Now, what about negative f of 1? Well, first, let's just start off by solving for f of 1. F of 1 is equivalent to negative 1 squared minus 6 times 1 plus 2. Okay, and after combining terms, we get that negative 1 minus 6 plus 2 is our reduced equation, and this simplifies to negative 5. If we were to negate this negative 5, we would get positive 5. Because remember, we're trying to prove that f of negative 1 is not equivalent to negative f of 1. And so this is true if it were that f of negative 1 equaled negative f of 1, then the function would be odd. However, we see that f of negative 1 is not equal to f of negative 1 because 7 is not equivalent to 5. Therefore, f is not an odd function. Okay? We're now going to determine whether or not option 2 is true. That is, does each function have a relative maximum at the same x value? And we can visually inspect the graph of g to determine that there is a relative maximum at the x value of negative 3. This yields a y value of 2. And a relative maximum is easy to spot visually because it's a local maximum where its y value is larger than all the other points that surround it. But eventually, as we see here, the function does surpass it. That's why it's only a maximum relative to the surrounding points. All right, so we've ascertained that there's a relative maximum at x equals -3. Let's see if this is the same for the function f. Now, we have to do what's called completing the square to get f of x into vertex form in order to determine where its maximum, the relative maximum that is, occurs. And note that this is vertex form that we're going to acquire after completing the square, where the h and the k represent the vertex, but you'll soon see we're not necessarily interested in the points of the vertex. We're really interested in this x value because this is going to tell us where our relative maximum occurs, okay? So this is our attempt at completing the square. We have here a negative x squared minus 6x. Okay, so now we want to know what two numbers will give us -6 when we add them, and what their product is in order for this to be a perfect square, okay? And so it's really +9 if we were to say we're choosing -3 and -3, but since the leading coefficient is a negative, we're going to just make this a -9. And to offset the fact that we are subtracting a 9, we're also going to add 9. And this essentially is saying that we're really not doing anything to the function. But in order to make this completely true, we also have to write in our +2, which was a part of the original expression, okay? But now we're going to shift things around in order to get the function to look something like this. So we're going to need to throw in a pair of parentheses. And what we can now do is extract the negative sign and encapsulate x squared plus 6x plus 9 around the first three terms. And we extracted a -1. Okay, there's no 1 written here, but this is a -1. And don't forget, that's how we got +6 and +9. Don't forget that we're still adding 9 and 2 to keep things balanced and algebraically legit. I know this is a little confusing, especially the part where we made this -9 instead of +9, but just know this technique. You've encountered it now you'll be familiar with it in the future, okay? So now if we combine the 9 and 2, we get 11. And if we make this term a perfect square, it's really the result of x plus 3 squared, okay? So here goes our h term, 3, and here goes our k term. It's 11, all right? But now that it's in vertex form, we notice that x only appears inside of the square, okay? The square itself can only be positive or 0 if we were to make x -3, okay? And there's a negative sign in front of this square term that we can't neglect. So therefore, the term can only be negative or 0. And what you have to consider and think about is that the function's maximum value will occur when the term inside of the square is 0, since this is a negative term that essentially can only be negative or 0, okay? So in this case, the squared term is 0 when x is equivalent to. Let's check option 3 and determine whether or not each function has the same y-intercept. And the y-intercept is the place where a function intersects the y-axis. That's the vertical line of the Cartesian coordinate plane. So here goes your y-axis, okay? All right, so now that we've established that, in order for this to occur, the x value obviously has to be equivalent to 0. So let's make this true for the first function f. We see that f of x equals negative x squared minus 6x plus 2. Now let's do f of 0. So f of 0 equals negative 0 squared minus 6 times 0 plus 2. Notice that we've plugged in 0 in the stead of x because in order for a function to intersect the y-axis, the x value has to be equivalent to 0. Okay? So after we plug in 0 for our x values and simplify the equation, we find out that everything is equivalent to 2. So the y-intercept of for f of x is equivalent to 2. In the same fashion, let's check the y-intercept for g of 0. And a simple visual inspection shows us that the y-intercept is in fact 0. And if we were to represent this as an equation, g of 0 equals 0. The functions do not have the same y-intercept because f of 0 is 2, therefore option 3 is not a correct selection. Now, in determining whether the last option is true, whether or not these two functions are periodic, well, the answer in short is that they're not because they don't repeat over regular intervals. And a visual inspection of g of x reveals this very easily because we can see that their end behavior is trending towards positive infinity on the right-hand side and negative infinity on the left-hand side. Okay, and what you can know is that this is a parabolic function because you have an x squared. It might be inverted and shifted, but it's still basically a second order parabola. And parabolas are not repetitive. Okay, so this is going to look something like this. All right, so basically it's not repeating, and it's also going to have a similar type of end behavior where it just continuously decreases both to the left and the right. Okay. Okay, so now after this rigorous series of exercises, we established that both functions have a relative maximum at x equals -3, so that means that option 2 is correct. But f of x and g of x don't share any of the other features listed in options 1, 3, or 4. Okay?